Hello, let's start with a brief summary. At the beginning of the course, we talked about managerial decision making. Then we talked about how information systems support decision making. Later, we also talked about the relationship between data, information, and knowledge. After that, we talked about information systems and information technology. And finally, we talked about the life cycle of data and different types of databases. And during the final part, I mentioned that relational databases is the core technology that we will use in this course. I also introduced NoSQL databases. Now, in this section, I want to give an introduction to relational databases, which is the main topic of this course. So I will start with a definition of relational databases from a technical perspective. Then with bicycle case and bookstore case, I want to mention the mentality of relational databases, how it works, and what kind of problems it tries to solve. So after this section, I expect you to understand what is a relational database. So let's start with some definitions. A database is an organized collection of data generally stored and accessed electronically from a computer system. So we talk about a collection of data in a computer system or in a system that a computer can reach. So we call it database. It is a collection of data. Here we have another term called Database Management System, DBMS, and this term is a software which interacts with end users and other applications to capture and analyze data. So you can think of database as a collection of papers in your desk, okay? Assume that each paper is a data, so you have a collection of data in your desk. And database management system is a system which organizes this bunch of papers, okay? One of them is the collection itself. One of them is the mechanism that you use to organize it. So there's a distinction between database and database management system. From a technical perspective, we can say a database is a collection of symbols that is organized so that it can be easily accessed, managed, and updated. So the database management system should easily reach the database and insert data, update data, etc. So if we focus on this last definition, we can say some other words like an organized term. The term organized means machine-readable collection, and here the organized term refers to structured data. In the last videos or last sections, we talked about structured and unstructured data. Here in relational databases, we focus on structured data. So they are organized somehow. And another important term here in this sentence is the symbol. We use the term symbol because when we go into deeper part of databases, we will talk about data types. We have text, we have numbers, we have dates, etc. There are different details. So up to this point, we call it symbols. It can be any symbol, but it is organized. Okay. So it is organized, and it shows as a part of reality. So as I mentioned before, data is a footprint of reality. So in a database, when you have some data, somehow it must represent a kind of reality or a part of reality. And a database is a collection of entities. There can be lots of tables or lots of different objects in your database. It is not like a single object. There can be lots of different objects in your database. And finally, I want to focus on the term users and their requirements. Databases capture data, analyze data, manage data, etc. But they do it for a purpose. They do it to generate a benefit for the users. And here, the users can be you, me, your friends, in general, a human being, or the user can be another system. So when you make an electronic fund transfer in a bank, indeed you touch your cell phone, you do some actions, but your actions are sent to another system, to bank's database. An operation happens there and turns back to your machine. In this setup, the user of bank's database is your software, not you. You are the user of your cell phone. So, in general speaking, human beings can use databases. It is possible, but generally, we use databases by some intermediaries, some different softwares. So, the real user of a database is generally a software. And as a user, you, me, or your friends have different needs when they are using the database or another software. When it uses the database, it has a specific need. We call these needs, or we can say the things that the database must accomplish, we call it requirements. So systems have requirements. They are organized or they are formed to fulfill some actions. People expect something to happen when they use it. So from this point, databases must fulfill some requirements. The databases are designed to fulfill these requirements, and these requirements are related with the users. So let's go into detail with some examples. Organized collection of symbols. Here on your screen you see a table. I mentioned before, but let me repeat one more time. Relational databases store data in tables. Tables just like you have on your Excel or your Word, or on paper, of course. So here you see a 3-column table with 5 rows. This is how data is stored in relational databases. Of course, it has some important differences between Word and Excel. There are some rules in database systems, like if you have a row for student ID, like the first row you see here, you must enter the student ID to that column. If you have a name column, you must write all the names under that column. If you have a course ID, you must enter all the courses to that column. So it is organized. It is not like Excel. When you first open an Excel file, it is not organized. There are lots of cells, empty cells, and nothing written there. Then you can start to form a table. So you organize it. But in relational databases, after you model, of course after the modeling phase, it is organized. So it is not like, oh, okay, shall I write the name or surname here? No, everything is obvious, everything is organized. Interpreted as a part of reality, here it means each row in a table shows something, shows a part of reality. You can build a sentence out of it, and this sentence shows or means something in the real world. For example, here, student, this is a table for enrollment. Of course, I must say it first. Enrollment of a student to a course, okay? So, in this row, for example, at the first look, maybe you cannot understand, but when you get familiar with the design, you can easily understand that this row, S1 Ayşe C1, means student S1, whose name is Ayşe, is enrolled to course C1. So, just like this example, each row represents a sentence or represents a part of reality in your system. Okay? This is something important because we design the tables or we design the database just like putting up some puzzle parts together to build a picture. Okay? This is a puzzle part, and when you have other puzzle parts designed in the right way, you can have a good picture. So that's how databases represents a part of reality. Of course, there can be other things in your real world. Ayşe has a surname, for example, or Ayşe can be enrolled to another course. Of course, other realities can exist, but here we only see a part of it, and we can somehow convert this to a sentence. And here, collection, we said collection of entities. Enrollment is a student's action to take the course, is just a part of relation. So in this table, we can see realities about enrollment. S2 Barış is enrolled to C1. This is another part of reality. S3 Ceyda is enrolled to course 3. It's another reality. But as a whole, enrollment is not the reality by itself. It's only a part of it. So there can be other entities, other tables in your database. So it is not like a one table to cover everything you need. You can have different tables. And at any time, a new data can be entered. Here, the S4 Taner is enrolled to course 1. We didn't have it before. Now we have it. It's just updated. These tables are dynamic. They can change any moment. And the relation is not equal to table, which means we talked about Ayşe, a student S1 named Ayşe is enrolled to course 1. It was in the first row when I first showed it. Now it's in the third row, and the columns are confused. So in the previous look, we had student ID first, name then, and then course ID. So both the row numbers and the columns are confused now. But still, the row here, Ayşe, this one, Ayşe, S1 and C1, this row is still a row, so it still represents a part of reality. So the format of the table is different from the reality. So you can have different column orders, you can have different row orders, but the reality itself or the relation must still be the same, because Ayşe is enrolled to course 1. This is reality. You are trying to show this reality in your table. No matter what type of table you have, what is the order of your columns, or what is the order of your rows. Okay? So you can have different formats of table in terms of column orders or row orders, but still the relation shows the same reality. It must be organized like this. So the table format can change, but the relation is still the same. So in other words, the relation represented does not depend on the order in which we place the rows or the columns in the table. We can say that the format of the table, the order are not so important. So let's take a deeper look at a row. So here we have a heading in the table. We call them attributes or properties. So here we have three properties: student ID, name, and course ID. And in each row, we have the attribute values. So for the first row, the value of student ID is S1. The value of name is Ayşe. The value of course ID is C1. We call them attribute values. And we call this row, I generally use the term row, but in some other resources, you can see the term tuple, tree tuple, n tuple. You can see or read this term. So it represents the relation. So now let's turn back to a previous slide, or let me bring you this screen capture. I used it before when I tried to introduce the database servers as an example. Here you can see a table. So I hope you can understand that it comes from a relational databases. And now let's take a few moments to think about the headings, the values, what type of columns it have. Let's think a little bit about this. So it's obvious that it looks like a table, so it is very easy to understand. We have an ID part here, which represents the user's student ID. Of course, I erase some parts so that it doesn't represent a specific student. I also erased the student names. And here you can see the final grades. You will have some final grades at the end of this course. So this is the third row here. Grade entry type we have. So most of them is an original entry. Then we have some different types. Now we don't have it. It was in the past. So we have change int. I don't know what is it. Did it change or not? I think it represents this one. So, and here it is the last transaction date. So we have 1, 2, 3, 4, 5, 6 columns. And here, for example, this second row here represents a reality, as I said before, like a student with a student ID 04, 01, 703, blah, blah. Let's give a fiction name like Ahmet Öztürk. Here has a final grade of BB, and it was originally entered. So the teacher entered the data on 20 of January, and after that time it didn't change. This part or this second row represents this reality. Okay, each row by itself represents different realities. So it is just a single table from a database.